which cannot be done alone. UNPAD believes that in the spirit of collaboration, this vision may be achieved. We invite you who have the same vision, a good intention to care for human life and the environment all over the world, to work with us, build collaborations, create a better world together.
Universitas Padjadjaran grew out of the community and has made it its duty to give back not only in the form of the dissemination of knowledge and information, but also through socially responsible activities such as student fieldwork, community outreach programs, and action research seeking to make direct impact on the community. With its feet firmly grounded in the local communities and environment, UNPAD is also making great efforts to take steps towards internationalization. It offers special programs for international students to maintain its global network and make its strategic and reputable place on the world map of higher education. As a site for the personal development of young minds and bodies, UNPAD supports a wide variety of student activities. UNPAD also provides students with libraries with an extensive collection of books, periodicals, and study materials, comfortable dormitories, health and fitness services, free on-campus transportation, and other supporting facilities which UNPAD continuously upgrades and improves. While being committed internationally recognized quality research, UNPAD maintains also its dedication in preserving traditional cultures as the compass for all of UNPAD's activities on and off campus. As of now, UNPAD have set forth unto society 200,000 graduates in various fields of work, including strategic government sectors and crucial multinational industries. Works for the good of society, bringing innovations and sincere contributions to humanity. Universitas Padjadjaran, the pride of West Java, working for the benefit of the global world.
Indonesia, negara kepulauan terbesar di dunia, dengan 2/3 luas wilayahnya adalah laut, memiliki 17.000 lebih pulau dengan panjang garis pantai sepanjang 81.000 km. Tak pelak, Indonesia memiliki potensi kekayaan sumber daya laut yang luar biasa, khususnya di sektor perikanan. Minimnya sumber daya manusia yang mengelola potensi tersebut menjadi tantangan tersendiri bagi perguruan tinggi dalam melahirkan tenaga ahli yang kompeten. Universitas Padjadjaran, salah satu perguruan tinggi di Jawa Barat, hadir menjawab tantangan tersebut dengan mendirikan Fakultas Perikanan dan Ilmu Kelautan.
Sejak tahun 1965, Universitas Padjadjaran telah menyelenggarakan pendidikan tinggi dalam bidang ilmu perikanan. Melalui surat keputusan rektor, berdiri Fakultas Perikanan dan Ilmu Kelautan Universitas Padjadjaran. Berdirinya fakultas ini merupakan respon dari keinginan masyarakat, khususnya masyarakat Jawa Barat, untuk dapat menghasilkan tenaga ahli atau sumber daya manusia yang kompeten yang dapat mengelola sumber daya laut dan perikanan. Saat ini kami diberi amanah untuk menjadi pengelola di Fakultas Perikanan dan Ilmu Kelautan Universitas Padjadjaran. Menghadapi revolusi industri 4.0 dengan tantangan yang semakin besar, institusi pendidikan dewasa ini dituntut untuk memiliki kegesitan dan fleksibilitas. Kami berkomitmen untuk menjadikan fakultas ini menjadi fakultas yang unggul dan berdaya saing internasional. Kami akan berusaha untuk menghasilkan para lulusan yang memiliki skills abad 21. Para lulusan yang mampu berkomunikasi secara global, para lulusan yang memiliki karakter yang jujur dan berintegritas, para lulusan yang mudah bekerja sama, para lulusan yang memiliki etos kerja yang tinggi, serta para lulusan yang mudah beradaptasi. Dengan kurikulum transformatif, kami yakin dapat menghasilkan para sarjana yang mampu menjadi pemimpin global masa depan dalam bidang perikanan dan kelautan.
Fakultas Perikanan dan Ilmu Kelautan Universitas Padjadjaran membuka 4 program sarjana dan 2 program magister. Untuk program sarjana, ada program studi perikanan, program studi ilmu kelautan, dan program studi perikanan kelas Pangandaran. Untuk program sarjana terapan, ada program studi pariwisata bahari. Dan untuk program magister, ada Magister Konservasi Laut dan Magister Ilmu Perikanan.
Fakultas Perikanan dan Ilmu Kelautan mengukir prestasi tanpa batas, ciptakan insan unggul, jujur berbudi luhur, kompetitif, kreatif, inovatif, berbijak pada keilmuan, menjunjung tinggi profesionalitas, ciptakan efektivitas bekerja dalam kolaborasi yang bahagia, semangat untuk bermanfaat dan mendunia melalui karya dan prestasi yang nyata, menyelam hingga ke dasar samudra, terbanglah hingga ke tinggi angkasa. Janji kami untuk selalu mengabdi bersama FPIK UNPAD. Janji kami untuk selalu mengabdi bersama FPIK UNPAD.
Good afternoon and welcome everyone. Thank you for sparing your time to be here. I'm to be your master of ceremony for today's webinar. My name is Rushka and I will guide the course for today's event. First of all, how's everyone been doing? I hope everything's well. Even though we're still stuck in between screens, it seems like all of you are still enthusiastic in wanting to expand your knowledge and insights by participating in this webinar. Before that, may all participants change their name to the format that will be sent on the chat box below, which is institution_name, and stay with the name throughout the webinar. And all participants are expected to turn on their camera and use the background that has already been provided throughout the webinar. Also, please be prepared for network conditions and all audio or mic are on mute so that the webinar runs smoothly. First of all, before we start the event, I would like to remind all of the participants to sit properly because in a few minutes, we will sing the national anthem. Moving on to the next agenda, our greetings from the head office of the Internationals of Universitas Padjadjaran to Dr. Roni. The time and screen is yours.
I'm very happy today and delighted with the event that had been held with the Faculty Fishery and Marine Science to have the event international lecture for the environment and human impact to sustainable fisheries. This has become our concern. Our university, Universitas Padjadjaran, put big attention to live in this earth with a sustained strategy. We follow with the grand strategy how university has impact to the society and bring the benefit most for the society itself. So by having this international lecture, we believe that our student, also our lecture, will get a lot of knowledge, experience, and also exchange in the strategy and technique how we will um, utilize the resources from the nature and make it sustain. In these cases, about the fishery. So we believe by having a very respected speakers today, moderated by Professor Fadli Syamsuddin, I do believe our students will learn a lot of knowledge and new strategies like I mentioned before. So thank you so much for the guest lecture and honorable lecture from Kobe University, Japan, Professor Manabu Yamanaka. Thank you so much, Sensei. And also Dr. Claire Vincent from the Melbourne University, Australia, and also from Kathy Lengo, Dr. Kathy Lengo from Strategic Research at Marine Stewardship Council. So we are very happy to welcome you in our university. We hope that this event, this international event, inviting the very prominent lecture from outside the country, will be sustained also, not only for a single event, but also for many academic and research engagement for the future. Thus, we are very happy to initiate this lecture. And I do believe not only me, but all the participants today cannot wait. What is the content in the lecture that will be delivered by the prominent lecturer that invited for this topic today. So without further ado, I will very happy to welcome all the speakers and then also the students on behalf of the Universitas Padjadjaran. We wish you have a very wonderful international lecture series today, and we hope that another interesting lecture series will be held for the future. Thank you so much, and then enjoy the lecture and gain a lot of experience. Thank you. Good afternoon.
Thank you so much for the greetings, Dr. Roni. Before going on into the main event, there will be another welcoming speech from the Dean of the Faculty of Fisheries and Marine Sciences, Dr. Yudi Nurul Ihsan. Time and screen is yours.
Yeah, thank you, the MC ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to all of the participants. First of all, I would like to thank to all of the audience. I believe these seminars will be very useful for us, and also this lecture will in line with the mission of the Universitas Padjadjaran, useful and worldwide. And I have to give regards to the participants. Yeah. First, Your Excellency, to the Pak Roni, the head of the international office,
And then Your Excellency to the Vice Dean of the FPIK, Faculty of Fisheries and Marine Sciences, University Padjadjaran, Your Excellency to all of the professor, the management of the faculty, and also Your Excellency to all of the speakers and the moderator, and Your Excellency to all of audience, especially to our students at the faculty. The second one, as we know that Indonesia is the largest or the biggest archipelago state in the world, with the many potential of the resources. And we hope that by these resources, we can get the mission of the Indonesian people to be the prosperous country in the future. Indonesia, known as with the mega biodiversity, with the reach of the natural resources, renewable resources, and renewable resources, and also natural or environmental services. And I hope by this seminar we can discuss how these resources will give the benefit for all the Indonesian people. But the question is how to transform these resources become an economic power in the future, become what we can say the activity for the growth economic, but still considering the ecological aspect. Of course, this is for the sustainable activities in the world. And the last but not least, I hope that this seminar is not only seminars or discussion, but we can follow by the other activities after that. And for the speakers, I hope this is not the last lecture in our institution, but maybe this is the first time. So that's why after this, maybe there is the second, the third, and the other lecture with our institution. And also we hope in the future we can make strengthen the collaboration, and the speakers also even from the Japan or from the other country will be a part of Faculty of the Fisheries and Marine Science, University Padjadjaran. I think this is what I can say. And by the greeting for the Allah Subhanahu wa Taala, we can start this seminar, and hope enjoy this lecture and get many benefit from these seminars. And I hope we can enjoy the discussion. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much for Dr. Yudi for the warm greetings. Before moving on to the next agenda, we will carry out a photo session. Therefore, we request all of the participants to activate your cameras and give yourselves a big smile. I'll give you some minutes for you to get ready to take the photos. We'll all ready on the count of 3. Here, I will lead the documentation session. Once again, to all the participants, please activate your cameras so you will be seen. On my command, in 3, 2, 1. Okay, I would like to remind all of the participants to turn on the camera before going on into the main event. Before starting the presentation, let me introduce the moderator who will lead the presentation along with the presenter by reading the CV. I would like to ask for the operator to share the screen. The following is the CV of the moderator who will lead the session with the speaker. In this webinar, the moderator will be Professor Fadli Shamsuddin, who's also a lecturer in the Faculty of Fisheries and Marine Sciences, Universitas Padjadjaran. This is the CV of our moderator for today, Professor Fadli Shamsuddin. His title is Director of Marine Affairs and Fisheries Department of West Sulawesi Province. He graduated from Royal Netherlands Institute for Sea Research and graduated from Rutgers University, New Jersey, USA. And his expertise is agency for the assessment and application of technology. That was the CV of our moderator, who is very impressive and surely inspires us all. To Mr. Fadli as today's moderator, time and screen is yours.
Thank you, Ms. MC. Today we will have a very excellent international talk actually with three most prominent scientists actually in the fields related to the themes of this afternoon meeting, the environmental and human impacts in the ocean, and improvement on sustainable fisheries. And we will have along mostly 1 hour 30 minutes because each speaker will have 30 minutes. With the first one, I would like to introduce Professor Manabu Yamanaka. You are here, Yamanaka Sensei. Hasishiburi, glad to see you again here virtually. So just give me a brief CP of Professor Yamanaka. He is actually a prominent professor in the Kobe University. He is, I believe, the most person that I know understanding very well about the Indonesian maritime continents. Why? Because during his CP, actually, he works mostly more than 30 years, I think, in Indonesia, and he pioneers many important projects in Indonesia. And last time, we worked together in BPPT and other university in Japan regarding how the climate, especially in transitional variation in the maritime continents. So just short BP of CP. His little title is now researcher at the Research Institute for Humanity and Nature, Kyoto, Japan, and also, as mentioned before, Professor Emeritus of Kobe University. So he graduated mostly in the master until PhD from Nagoya University. So currently, he's a collaborative research institute for humanity of nature. So I think he will give a talk, very important talk actually, to start with the all students here. Yeah, Indonesia, maritime continents in the perspective of climate change. So you have a 30-minute Yamanaka Sensei, and time is yours now.
Okay, thank you very much. So, first of all, it is unfortunate that I cannot visit University of Padjadjaran. It was probably more than 25 years ago I have visited your university, Padjadjaran. When I stayed in ITB for 1 month in probably 1994, etc. So I still remember the beautiful campus of university, and I am very unfortunate to not to visit your university this time. But I'm very happy for your kind of invitation to this very important lecture opportunity. And I will do my best to talk about, in particular, major topics related to recent so-called climate change issue, and also recent issue of how to say, how we what is an important subject to take care of the risk of climate change. So anyway, I will start. So may I share my slide, and please wait a minute. Did, could you find my slide?
Yes, Sensei.
It's okay.
We saw
Okay,
it
so
already.
I will start my lecture, and any questions are welcome on probably chat box. So I will read your chat box after my lecture. Okay, so first of all, now how to say your country, Indonesia, is a very hot place on considering global climate. The climate, of course, important for people living in Indonesia, but not only you, Indonesian people, but also all of the people living in this planet, Earth, how to say, related to your climatic situation. And later I will mention some important phenomena such as El Nino, etc., which is related to the oceans surrounding your country, Indonesia. But before that, I will introduce several beautiful photos. This is taken by Professor Casino. Probably Fadri, Professor Fadri also familiar his name, and he is now working in Fisheries University in Japan. And anyway, this photo is very beautiful, but not only beautiful, but also important, because this photo covers several very important things of your country. First one, your country is island. Probably this island is Timor, etc. I don't remember the name, but anyway, this is island of your country. And there is sky, of course. And there is a sea, of course. So simply speaking, your country is having many islands and surrounding very, simply speaking, very warm water ocean. And also very beautiful sky, sometimes covered by clouds, sometimes very clear blue sky. And this, simply speaking, cloud activity is a major topic of your lecture, which is very important member to control our global climate. The time is limited, so I have no time to mention this subject. But this is a volcano of your country. This is also important to control our global climate. But anyway, simply speaking, cloud is contributing both atmospheric warming and cooling, because cloud can reflect sunshine. So this means cloud can contribute climate cooling, but also cloud emit so-called latent heat. So cloud contribute warming. And also atmospheric situation, including greenhouse gas, which is transported by atmospheric circulation, and atmospheric circulation is enforced by these clouds. So cloud is contributing both climate warming and cooling. On the other hand, volcano is contributing atmospheric cooling, because this smoke covered Earth. Then atmospheric climate is losing solar energy. Then climate is cooled. So anyway, all of them are familiar for you. You are familiar for all of them, but these phenomena are truly important for global climate. Also, now, as in speech of your dean and meeting master, your country is now rapidly developing. So, simply speaking, various natural forests is cultivated for plantation-like broad place. Also, your capital city, Jakarta, is having biggest population and the biggest number of cars in Southeastern Asia, or probably within how to say number 10 of how to say biggest city of over the world. So anyway, these simply speaking, human activity is also affecting our global climate. So this is a very long introduction, but these beautiful photos taught us how your situation, your climate is important for our global climate. Then probably some students are not familiar this term maritime continent. Now many climate scientists all over the world called your country as maritime continent. Who or when called your country maritime continent first time? In my knowledge, this is the old record. So this textbook said one of the major islands, Sumatra of your country, has an original meaning in Indian language, Sanskrit, namely the meaning of sea land. So this means that your country is originally important of your ocean and land, and both or coexistence of land and ocean is very important point to control our global climate. But more recently, most famous paper using the name maritime continent, first one is published by this Professor Ramage, is the founder of Department of Meteorology of University of Hawaii in United States. And unluckily, he passed away several years ago. But anyway, he used the term maritime continent for the first time. Why he called your country maritime continent? Because at that time, he started tropical meteorology very, very early years, 1960s. Then there are not so many data covering equatorial region. So he used thunder data, thunderstorm data for tropical research. Then he noticed, okay, two continents, South America and Africa, are very active place of cumulonimbus cloud, convective clouds, to make thunderstorm or a very serious, very torrential rainfall. But he surprised, oh, Indonesia is sometimes more active rather than these two continents. And probably this is a moisture amount. Then concerning moisture amount of his data very long ago, Indonesia is number one. So this is a very important place for water cycle because water vapor moisture is one of the stage of water cycle, including ocean. Then he named the maritime continent. So your country is a very important place rather than two true continents, namely South America and Africa. Then this is a very famous paper, and you can download free of charge this paper if you notice this very important paper. Then probably Professor Wadori know him because he's one of the very important professor in physical oceanography and professor of University of Columbia in United States. Then he named global warming for the first time in scientific community. And also his very famous work is to clarify oceanic circulation is passing your country. So this means that your country controls this very important ocean global circulation. Then if you I recommend his very famous textbook, and the first version could be downloaded freely in this URL. So all the students could read this famous textbook to learn how climate or Earth system is complex but organized very sophisticatedly then atmosphere, ocean, earth, and also biosphere, namely animals, plants, and also human beings are connected to each other to maintain our beautiful planet Earth. Please learn this. This is very greater than my 30-minute lecture, so I recommend to read this textbook. Then, finally, I would like to introduce one of my old colleagues, Professor Manabe, who took Nobel Prize of Physics of this year. This is very historical, very memorial, because normally Nobel Prize in Physics provided only pure physics like nuclear science or thermodynamics or physical engineering, etc. But nobody obtained this prize as a geophysicist or a meteorologist. So Professor Manabe is now first professor obtained this famous prize, Nobel Prize in Physics. Why he obtained this? Yes, because he obtained the successful climate simulation by global warming for the first time. It is also 1960s. Then he, obtained the results that, for example, if the carbon dioxide is increasing, atmospheric temperature is slightly, very slightly, probably you consider, but it is very important because if this if this ground temperature is warming, then all the atmospheric layer have effect. And then, on the other hand, upper atmosphere is cooled down. Then this means that atmospheric heat exchange is keep mainly in the lower part of the atmosphere. So simply speaking, the increase of carbon dioxide is truly risky to warm up our climate. Then second person, Professor Hasselman. Professor Fadri, have you met him? I have met Professor Hasselman only one time in Sendai, Japan. Anyway, he did also an important climate model, and he did many calculations, and he analyzed the results statistically. Then we understand now, okay, so of course, correct climate prediction is still not so difficult, not so easy, but we can understand how the, artificial effect is contributing reduce of variance of climate. So this is also a very important subject. So now we understand, okay, so climate is fluctuating, but the result is truly affected by human activity. So these two important professors have a Nobel Prize this year. And simply speaking, why these professors obtained a successful result? Because the greenhouse effect was discovered very long ago, more than 100 years ago. But no professors could obtain successful results of successful simulation of global climate. It is because not only greenhouse gas, but also water is very important. Firstly, as Professor Fadri knows well, ocean is a very important member to control our global climate. Secondly, the water cycle, namely water exchange between ground surface and the sea surface and the atmosphere to make cloud and rainfall a very important process of the climate control. So if you control this realistic atmospheric structure by numerical model, anyway, these two members, namely ocean process and hydrological process, should be included. If not, successful results could not be obtained. So Professor Manabe and Professor Hasselman did these process actually. Then now nobody doubt the human effect of climate change. Yes, so we will mention something later in my lecture. Then, how to say, yes, probably time is limited, so I must skip some slides. But anyway, this Hasselmann's results also including some volcanoes here. For example, Gunung Agung is a famous volcano in Bali, Pulau Bali. And then if volcano is erupt, how to say, this effect is working as a cooling effect on the climate. Actually, very long ago, yes, more than 100 years ago, two famous volcano eruptions. One is Krakatau. Krakatau also recently erupts, but 100 years, more than 100 years ago, the island was broken completely. Then the how to say, volcanic effect is very important from your country. And this is how smoke of the volcano Krakatau is covered globally our planet. And then more half century ago, how to say, more strong volcano eruption occurred in Indonesia, and also more long ago, 75,000 years ago, more strong volcano eruption, namely this is namely now Lake Toba in Sumatra Island. This is how to say, result of a very broken eruption of a big, very big volcano. So anyway, your country is also affecting such a volcano effect on the global climate. But I have no time to say details, so I go ahead. And if you want to obtain most recent summary of our global climate change, please download this book from internet, also free of charge. This is the URL, and or if you forget this URL, please browse the IPCC AR6. So if you obtain this book, and this book mentioned how our climate is very dangerous to be changed completely. So please read this book. Yes, so now we are standing on 2000 here, and in particular after 1970s, climate change is warming is accelerating very much. Then carbon dioxide or other greenhouse gas is emitted also rapidly after these timings. So if we continue this process without stopping, the climate becomes warmer and warmer and warmer. So for the future, including you, young generation, you have many damages in the future if our climate is not recovered. So there are many simulations, so you can read these results also from the IPCC book in the previous slide. But as I mentioned, as Professor Manabe clarified, how to say, not only greenhouse gas here, but also hydrological cycle and ocean process are very important to control, say, imbalance between radiation process. Yes. So how, if atmosphere is warmed by greenhouse gas increase, atmosphere itself will have a resilience or have some recovering effect inside the atmosphere or Earth system. Namely, probably hydrological process and ocean process will work to recover the climate if human beings will make a modification of a climate. But of course, natural effects have a limitation. So we need to learn how hydrological process and ocean process are controlling present climate. Then, for example, equatorial region, tropical region is the most important place of both of two processes, namely cloud rainfall and ocean circulation. For the hydrological process, many rainfall are coming to ground in tropical latitude. In particular, Indonesia is the number one place, number one area to make a large rainfall over the world. Then, simply speaking, how rainfall is coming? Yes, the origin of rain cloud is water vapor. Where water vapor is transported from? Yes, from ocean, the sea wind will bring plenty of moisture to the ground. Then rainfall is coming to the ground. So simply speaking, if we want to study Banjir flood river flow or torrential river rainfall, you need to consider how moisture is transported from ocean to ground. So like this, ocean and hydrological process is truly important. And then the results of cloud and rainfall is controlling or how to say, compensating the imbalance between greenhouse gas effect and other radiation effect in the climate. And as I said, the maritime continent Indonesia is the number one place of rainfall. This is also obtained from the older version of IPCC textbook. So anyway, as you see, observation and also numerical model indicate your country is the center of convective rainfall. So you understand how your country is important for global climate. And this simple graph is called Clausius-Clapeyron diagram. You have learned this diagram in the faculty freshman course physics or something. Then, simply speaking, so-called saturation vapor pressure is increasing rapidly with temperature is increasing. So simply speaking, if temperature is warming by only 3 degrees, the 20% increase the maximum humidity on the atmosphere. And the results, you'll imagine, yes. So if atmospheric moisture is increased, the rainfall is simply speaking increasing. So how to say, the risk of Banjir is increasing very much if global warming is caused. But meteorologists say, if you consider, simply speaking, correct weather forecasting, for example, namely the condition of rainmaking, it is not so easy. So simply speaking, even in tropics, even in your country, rainfall is not easy thing because atmosphere is itself a very stable structure. So if cumulonimbus clouds want to grow up, stable atmosphere will suppress cloud development. So this is a true mechanism of atmosphere. So if cloud development, we need some special condition to grow up cloud development, accelerate cloud development. So first one is so-called cyclone, or how to say, front, which appears only in extratropics. So your country or tropical country do not have strong cyclone so frequently or do not have front structure. So this mechanism one is useless in your country. Second one cause is typhoon. Typhoon is one of the category of cyclone, but typhoon is of course sometimes coming in your country, but only 1 or 2 in 10 years or something. And the strength is not so strong. But if you go to Philippines, for example, you will see every year very strong damage of typhoon. And for making a typhoon, you need so-called Coriolis force. Namely, your tropical region do not have Coriolis force because your horizontal plane is almost parallel to Earth's rotation axis. So equatorial region do not have strong typhoon. So simply speaking, this second mechanism is also useless in your country. The third mechanism is okay, very powerful in over the ocean. Probably you have many lectures from Professor Fadori or some other oceanographers. Then so-called intraseasonal oscillation or so-called Madden-Julian oscillation causing very large-scale cloud system. Then that cloud system making very strong rainfall or a very strong effect of cloud over the ocean. But luckily or unluckily, you are living in island of Nusantara, Indonesia. Then, how to say, Madden-Julian oscillation should be modified before landing your country. So, unluckily or luckily, this third cause of strong rainfall is also useless on your country. So, final but the most important process to make rainfall is I don't know, you learn this in elementary school or junior high school, so-called
William Sensei.
You learn.
Yeah.
Okay. Diurnal cycle between ocean and land. Simply speaking, land is solid and ocean is liquid, of course. Then if you boil up both solid and liquid at the same time, always solid becomes hotter or more quickly hotter. Then the land surface becomes hot. Then this is the source of strong convection on the land, in particular in the late afternoon, probably around this time. You are now in 2 o'clock or something, and then now you have clouds on the sky. Then this is a diurnal cycle on land, namely from the late afternoon to the evening, this cloud making rainfall over the land. On the other hand, on land, how to say, the land is cooled down again more quickly rather than sea surface. Then sea surface is now in nighttime more warmer than land surface. Then at that time, in the evening to early morning, sea surface is covered by cloud. This is how to say, most important effect of rainmaking. And the final effect, this is the airflow. Wind is passing over the mountain. Yes, you have many mountains, many volcanoes, many gunung, banyak gunung ada di Indonesia. Then, how to say, now you have also a very important effect from this high mountain. But probably you must note that. Of course, you have volcanoes. But volcano is sometimes, how to say, some volcano in the one island. Java Island have several volcanoes, but not everywhere covered by volcanoes. But your island, Java, for example, is surrounded by coastline, and all the coastline have a source of diurnal cycle. So diurnal cycle is more basic, and the mountain effect is secondary. Then you have a very strong rainfall over your country. So I summarize the several variability of rainfall over your country. Probably you know El Nino, so later I will mention again. Then how to say, if no El Nino, or sometimes we say La Nina, and actually this year we will go to La Nina now, but anyway, in case of La Nina, in particular in rainy season, you have a very strong cloud here over the Indonesian maritime continent. Then, how to say, you have a strong moisture flow from both ocean beside your country, then you have a very strong cloud here. This is the first one. But yes, the effect is strong. But luckily or unluckily, this effect appears for once every 4 years or something. So how to say? You remember how frequently flood, strong flood appear in Jakarta city, for example. Of course, small flood appear almost every year, I know, but strong flood appear every 6 years, 7 years, or 3 years. Anyway, not every year. So if you take average per day, for example, the effect of ENSO or El Nino is not so strong in Indonesian maritime continent. On the other hand, you have a rainy season, etc., and every half year you are covered by strong cloud. This is rainy season, and then other half year you have a clear weather. This is annual cycle or monsoon cycle, and this is of course important. In average, this is 5 millimeter per day. This is very strong. On the other hand, as I said, over the ocean, here is a cloud system, very large-scale cloud system called Madden-Julian oscillation. This is again important for over the ocean, but for land, it is not so strong. Then the final member is the annual cycle. Every day, sun is coming, and every evening you have a strong cloud here. So roughly speaking, the annual cycle number one, and then annual cycle secondary, then El Nino, La Nina, or La Nina is major rainy phase. Then this effect is third one. So your country have a major 3 effects. Then. And now, how to say, we are standing here. And,
Sensei, 3
yes,
minutes left, Sensei.
Okay. So anyway, time is limited, and now our climate is again going back to La Nina. So I'm afraid this rainy season, you have many rainfall in Jakarta city or something. Yes, so every day rainfall is coming, and if you have a numerical model, you can simulate also sea breeze, land breeze every day. And then, how to say, this is how to say, simple calculation by Dr. Mori. He is now important person in Jamstek. Then, how to say, this is rainfall data by meteorological satellite. Have a very simple calculation of morning rainfall minus afternoon rainfall. Then all the land area is covered by blue. This means the land area have, as I said, rainfall in the evening, and ocean side have rainfall in the early morning or very late night. And every time the, how to say, rain cloud is moving between land and ocean. And river flow also have a diurnal cycle. This is a doctoral thesis of Reni in BPPT. She is a very important colleague of Professor Fadori when he worked in BPPT. So anyway, as I said, river flow is a result of sea breeze transport of moisture. Then if this sea breeze have a diurnal cycle, river flow is of course having diurnal cycle. Also, monsoon have a very strong effect to intensify the diurnal cycle, but I have no time, so I go ahead. And this is how to say record of 2007, 2013. This is a very serious bandel in your country. I have no time, but now you are Badan Meteorology and Geophysical BMG have a very strong radar system to cover how to say rainfall region every day, every night. And now we are living in so-called boundary layer. Then now, how to say, this is very close to coastline. So this is why we have a risk to have a very strong damage of climate disaster like very strong rainfall, etc. Then, how to say, until now, human being established agriculture, and the agriculture is started very long ago, more than 10,000 years ago. After that, how to say, our so-called anthroposphere, namely human living space, is separated from natural biosphere, namely forest or something. But now human activity is invading natural forest. Then, how to say, in particular for fishery issue, even now, different from land agriculture, fishery is not separated from natural ocean. This is also important subject to study fishery related to climate. Then this is a result of modification, but probably I go to the last slide. Yes, so now we have learned your country is very important on how to say global climate, and the most important process is diurnal cycle rainfall, which makes greatest rainfall of your country, which controls global climate. So anyway, please learn global climate by yourself to download a good textbook I introduced. Thank you very much, and please, sorry, I apologize. My time is longer. Thank you, and sorry, everybody.
Thank you so much. Please give big applause to Yamanaka Sensei. Very inspiring, Sensei.
Yes.
But I will hold for any question after the two other presentation.
Okay.
So can you close the
yes.
screen? Yeah. And I would invite Dr. Claire. Are you here, Claire?
Oh, yeah. Yes, I'm here.
Yes. Thank you so much, Claire, for accepting our invitations. So I just thought briefly give you a CV here. So Claire Vincent is a senior lecturer in the School of Geography, Earth and Atmosphere Science at the University of Melbourne, and a CI in the Australian Research Council's Centers of Excellence for Climate Extreme. Her research interests mostly includes tropical variability, extreme rainfall, that's Professor Yamanaka also mentioned, and I believe you will present more diurnal cycles, land sea breeze circulation more in the coastal process. And she also actually expert in wind energy meteorology. So she completed her PhD and a postdoc at the Technical University of Denmark from 2007 until 2014, where she works on mesoscale wind variability over the nodes and Baltic seas. She then moved now at the University of Melbourne. So at the moment, she will present about weather and climate variability in the coastal tropics. So Claire, your time is 30 minutes.
Thank you very much.
Yeah.
I'll share my screen.
Yeah.
Yep. Okay. Okay, can you see my screen?
Yes.
Great,
already.
Thank you. Thank you so much for inviting me to give this lecture. I'm really honoured to have this opportunity. We do have some tropical weather and climate variability in the northern part of Australia, but down here in Melbourne, we're more likely to see drizzling rain in winter and scorching hot, dry summers, which is what we're coming into at the moment. So it's really great to talk to people in the Maritime Continent region. So I'm going to start my talk today by talking about the land sea breeze circulation, which Sensei Yamanaka also discussed, but it's just so important for so many things that happen in Indonesia. So as we know, the land sea breeze or the sea breeze happens when the land heats up during the day more than the water. And so we get air rising over the land, we get lower pressure over the land, which causes this onshore flow and sets up the land sea breeze circulation. So the land sea breeze circulation is not specific to islands, and it's not specific to the tropics, but it's really special when we've got islands. And the reason why it's special when we have land sea breezes around islands is that when we get this onshore flow in the afternoon, all around the coast, perpendicular to the coastlines, then those winds converge in the middle of the island. That air's got nowhere to go except upwards, and that causes it to form clouds and convection. And then in the evening, we have the opposite process going on, where the land is cooler than the sea, and we have the winds moving offshore, and again forming convergence around the islands, and leading to cloud patterns, something like what's shown in this cartoon version of an island under the influence of a land sea breeze circulation. Now, if that island happens to have a mountain on it, then we also get local flows up and down the mountains. So in the afternoon, when the land of the mountain heats up, we get surface heating, and because of the slope of the mountain, we get hot air at the surface below the cooler air that's a bit further away from the surface, which leads to this flow up the slopes of the mountain. Again, we get convergence and clouds forming at the top of the mountain. And we have the opposite effect in the night time and the early morning with convergence forming around the lower land around the mountains. Now, it just so happens that the land sea breeze circulation and the mountain valley flows around the topography match up in time. So this impact of the land sea breeze circulation together with the mountains tends to form these patterns of clouds on the land during the daytime and then moving offshore to the seas during the nighttime. And this is exactly what we observe in Indonesia. So you can see this occurring just about now. You've got the land, the clouds forming over Java and Sumatra and then moving offshore in these squall lines. So the islands of Indonesia are the perfect place for this to happen. They're almost the most perfect place on the planet for this to happen. That's because we've got a large collection of islands with long coastlines, has already been mentioned. They've got quite steep mountains on them to get that extra forcing from the upslope flows. And they also sit in warm sea surface temperatures, and they are subject to large regions of tropical instability approaching from the Indian Ocean. So all these things combine to make the perfect recipe for clouds and convection and storms in the region. And actually, what all this combines to mean is that on an area average sense, Indonesia and the islands surrounding Indonesia are the rainiest place on the planet. So this map down the bottom shows that average annual precipitation. And you can see there are some other areas in the tropics between South and North America where there's quite heavy rainfall. But if you look on a sort of large area, it is the rainiest part of the planet. Now, the processes I talked about with the sea breezes and the islands, these things could happen in islands anywhere. But in the tropics, partly as a result of the low Coriolis force, these processes are even more interesting. And that's because these cycles of heating and cooling of the land with the sun coming up each day can survive as sort of waves or disturbances that move offshore hundreds of kilometres. So this is a simulation. It's actually through New Guinea, but it could be through Java or Sumatra or several other islands. When it's red, that's the land heating up. And so it not only heats up over the land, but then it moves offshore upwards and outwards, and we can track it for hundreds of kilometres. Now, the reason why that is so interesting is that these tropical daily processes of heating and cooling end up dictating what happens to the rainfall as well. So in this movie here, the purple lines are the rainfall, and you can see the rain building up over the mountains during the day and then sort of marching offshore and continuing to have some kind of daily aspect to it, even when you get several hundred kilometres away from the coast. So these diurnal processes control just so much of what goes on in the region. We can even observe these processes in the winds, these disturbances in the wind from space. So at the top here, we've got the land breeze circulation as observed from a satellite, which is measuring the near surface wind speed based on tiny ocean capillary waves. And you can see those sort of halos, those rings of land breeze circulations moving offshore around all of the islands of the region. And when we look at the mean rainfall signature, which is down the bottom in green, you can see how connected those daily processes are to the coastlines. You've sort of got those rings of enhanced rainfall around the islands, as well as on the slopes of the topography. And if we look at the time of day that experiences the maximum rainfall, which is what the bottom right plot shows, we can see that over the land, we get maximum rainfall occurring in the late afternoon and evening. And then we've got these rings of progressively later and later rainfall peaks occurring as you get further and further away from the islands. So it's really difficult to observe all of these processes at the same time. That's because we have to look at things on a really large scale to get that kind of overview and the large scale tropical disturbances moving through, but it's also interacting with daily processes from hour to hour, and it's interacting with the complex topography and coastlines. So we have to come at this problem from multiple angles to be able to really see what's going on. One of the things that we can do is measure the rainfall from space, which is what the left-hand plot shows. But then that doesn't show us the really fascinating small-scale variation, which is what we see in the middle plot, which is a result from Sophia Lestari's PhD, who did her PhD with us recently and has recently returned to Indonesia, who used the weather radar to track the peaks in rainfall following every little peak of topography around the Jakarta region. And then we have a small handful of ground stations, often located in difficult terrain, complex topography, where we can really drill down to the individual processes of what's going on and the relationship between the sun coming up, heating the surface, and then ultimately getting clouds and precipitation. But it's not all about the daily processes. If it was that simple, that it just rained every afternoon, and then the rain moved offshore every morning, then all weather forecasters would be out of a job. So it obviously doesn't happen like this every day. And in particular, at some times we get these really, truly catastrophic flooding rainfall events. And this is when we've got larger scale processes interacting with the topography in the mountains and the coastlines. This is an example from the master's thesis of Fadhil Muhammad, who's doing his project with us at Melbourne, and hopefully will be able to travel to Melbourne soon. And this is an example of the New Year's Eve, New Year's Day floods in 2019, 2020 in Jakarta. And in this case, we had this burst of really strong winds coming down from the South China Sea towards Jakarta. And also we had southerly winds as well, and we had this intense rainfall event. But if you look at the rainfall map of this event in the bottom right here, you can see just how local it is. So it's coming from this really large scale process, but then the interactions with the coast and the topography means that it's really detailed, you know, where it happens and where it doesn't happen and where exactly the rainfall occurs. And you can see here again the strong winds impacting on the Java coastline and the regions of enhanced rainfall. So I mentioned things happening on different scales. So we've talked about the diurnal cycle, but there's a whole family of disturbances that also make their mark on the weather and climate of the region. And these include things like the Madden-Julian Oscillation, monsoons, ENSO and the IOD, climate change, and other tropical disturbances. This map here is from 2 days ago, showing that outgoing long-wave radiation anomalies, you don't need to worry about what that is, other than to know that blue means cloudy and orange means less cloudy. And so you can see this big sort of blob or region of cloudiness approaching Indonesia. And this is actually a sort of a weak Madden-Julian Oscillation event approaching the region. I'll talk a little bit more about that in a minute. So I'm just going to talk about briefly how some of these processes impact the weather and climate in the region. And the most famous one, I guess, is ENSO, which is the oscillation between El Nino and La Nina conditions. So under El Nino conditions, we have cooler sea surface temperatures in the Eastern Pacific and warmer sea surface temperatures. Sorry, I've got the other way around. Warmer sea surface temperatures in the Eastern Pacific and cooler sea surface temperatures in the Indonesian region. And under La Nina conditions, we have the opposite. And so when we have those warmer sea surface temperatures, we've not only got enhanced rain and storminess in the Indonesian region, which is what we're possibly facing this summer, but it also sets up changes in the global circulation pattern, which is why ENSO has such far-reaching effects. And indeed, down here in Southeast Australia, El Nino conditions bring us our most severe fire seasons. So a sort of cousin of ENSO is the IOD, the Indian Ocean Dipole, which is sort of working in a similar way in some ways, but over the Indian Ocean. So this is sort of an oscillation between warmer sea surface temperatures in the Western Indian Ocean and cooler sea surface temperatures in the Eastern Indian Ocean, and the reverse. And then we have the MJO, the Madden-Julian Oscillation, which is a curious big region of cloudiness and convection that tracks eastwards at about 5 meters per second from the Indian Ocean to the Pacific Ocean, and brings with it increased storminess and rainfall as it moves. And here it is, here's sort of 8 stages of the MJO as it moves across the region. And you can see very much like what I showed you in the real plot, the plot from 2 days ago, this is an average, how we have this region of cloudiness moving across. So those are all regular things that are happening all the time. And then on top of this is the backdrop of climate change. And this is where it all gets really confusing. I made this plot from the IPCC Interactive Atlas. And I made it from the IPCC Interactive Atlas because it might be something that's interesting to go and have a look at. It's really easy to use if you just Google IPCC Interactive Atlas, and you can zoom in on whatever region you're interested in and look at all sorts of climate impacts like temperature and rainfall extremes, and look at different selections of models, for example. So this particular one I've pulled out is looking at the wet season percentage change in rainfall over the Maritime Continent region from an ensemble mean of CMEMT models. And we can see a modest increase in precipitation in most regions, although there's not particularly high certainty on all of those signals that you can see. And indeed, when we look at the Maritime Continent or the Indonesian region in climate models, there's a great deal of uncertainty. So this is like little thumbnails, you don't need to look at them in detail, other than to see that this is a whole collection of climate models expressing our future climate, changes in, I think this is changes in precipitation. And if you look into them, you'll see that they're all quite different from each other. So we can have a mean change coming from lots of different models, but there's also the spread in that change, and there's not always good agreement between the models in what's going to happen. And one of the reasons why we think the Maritime Continent or the Indonesian region is quite tricky to model is this interaction between the really small scale processes and these larger scale processes. So it's really on a climate model. So you can see the kind of pixelation of these plots. That's sort of along the lines of the resolution of a climate model. That's not really resolving these detailed coastlines and mountains that you have in these regions, and these feedbacks between all that explosive tropical storms and the larger scale processes is actually quite important. The other really interesting thing about climate change in the region, and indeed anywhere, is that we can look at changes in the mean rainfall, but maybe more important than changes in the mean rainfall is changes in the extreme rainfall. And they don't always do the same thing. You could have the mean rainfall staying the same, but it could be distributed into a smaller number of really extreme events, for example. Or you could have the mean rainfall staying the same, but it could be distributed into lots more smaller, less extreme events. So just because we know something about what the mean rainfall climate is doing, it doesn't necessarily tell us what the extreme rainfall climate is doing. And this is an example here looking at several climate models where at the top they're looking at the total precipitation or the mean precipitation, and at the bottom they're looking at the 95th percentile of rainfall, so the really extreme events. And you can see that you've got quite different signals in those means and extremes. That's really tricky because the extreme rainfall comes from events that are really quite difficult to capture in these kind of modelling systems. Okay, now I'm not an expert in marine life at all, but I did do a little bit of research in the lead up to this lecture to look at the impact of some of these modes of weather and climate variability in the Indonesian region on phytoplankton and chlorophyll A, which are in some cases can be proxies for marine life. So this, I think most of these results are observed from space based on the colour of the ocean. Oh, so this one's not from space. This is an older study, actually, going back to 1997, where they simply looked at the skipjack tuna catch in La Nina and El Nino years. So they looked over just 2 seasons in 1989 and 1992. And this is, I guess, largely attributable to the differences in sea surface temperature. But what I thought was really interesting here is it's a whole different distribution of where the fishing has taken place under those different conditions. Then this is a study that looked at the impact of the MJO, which is this sort of slowly varying set of conditions marching across the region, taking about 50 to 90 days to get there. And on the left-hand side is the December, January, February chlorophyll A anomalies in different stages of the MJO. And so you can see that on the left-hand side is the rainfall anomalies, which we're quite familiar with, but we can also see this quite significant variation in the chlorophyll A anomalies with the propagation of the MJO. Now, I don't think this is a simple process. I think there's probably a whole lot of things going on here. There's different amounts of freshwater discharge, there's different sea surface temperatures, there's different amounts of cloudiness and radiation reaching the surface. So unpacking the processes and what's going on behind this result is probably quite fascinating, but I think it is really interesting to note that there is this kind of slow variation in ocean marine life processes. This is a similar study looking at phytoplankton biomass via chlorophyll A again, and the variation with the stages of the MJO. And I think this plot is really clear, showing the differences in this sort of regular periodic variation. And ENSO, we know has this impact on all sorts of things in the maritime continent. So not only rainfall, which we know about, but chlorophyll A up the top, and sea surface height anomalies and freshwater discharge as well. And the Indian Ocean dipole, possibly according to this study, has a stronger impact as well on the chlorophyll A concentrations in the region. So I've really enjoyed looking into these marine life impacts of the MJO and ENSO and the IOD that I have to admit I didn't know about until I was preparing for this lecture. And again, here I just put this one in here because it's just so amazingly detailed, looking at the chlorophyll A from space in that sort of really complex region between Java and Sumatra, and this under positive IOD and neutral IOD conditions. So I'm just going to end by saying that we often think about the variation in the maritime continent. It's easy to sort of think about things like the MJO moving over the region and varying the rainfall, but things are never as simple as they seem. And when you drill down to the highest, most detailed resolutions, things are really, really local. We can get signals on one mountain that are different to the next mountain, for example. Or sometimes things even go in the reverse direction to what we expect. This is a really lovely result from Sopia's Lostari's thesis, looking at the rainfall just before the MJO starts, during the MJO, and once it's moved out of the region. And it's not only the amount of rainfall that changes, but it's the nature of the rainfall. It's whether we've got those short, sharp peaks of sudden heavy showers or whether we've got more prolonged periods of less heavy rain. And we see this as well when we do really high resolution modelling that can sort of zoom in and resolve all those individual mountain peaks in the region. And that's something that we don't often get to when we're looking at sort of longer term climate change signals. So this is a really exciting place. There's just so much going on. There's some things that we do know. We know that sea breezes and coastal processes, ENSO, the IOD, the MJO, and other tropical disturbances can all play a role in modulating the coastal and ocean weather and ocean nutrients. We know that coastal processes, what's going on at the coast, can influence the ocean weather several hundred kilometres away from the coastline. We know that changes in extreme rainfall are not the same thing as changes in the mean rainfall. And we know what we don't know, in that we know that changes in rainfall are uncertain. And something else that I pulled out of the IPC summary for policymakers for the Southeast Asian region is that compound events are likely to exacerbate climate change. So compound events are where we've got more than one thing going on at once. So we've got strong winds and rainfall together, or rainfall and landslides together, for example. On the other hand, there's heaps of things that we don't know. And here's just a few of them. One of them is, how will the Madden-Julian oscillation change in the future? Another one is, how will the ENSO and IOD change in the future climate? And then the really tricky one is, how will the interaction between all of these things occur? We don't really fully even understand that now in today's climate. And then the other really interesting question is, how will the local response to all these large scale things change in terms of the sort of extreme rainfall events and the very localized rainfall? Thanks very much.
Thank you so much, Claire. So give big applause to Dr. Claire. Very interesting, actually, the presentation. So you give all together with Professor Yamanaka from the conceptuals of the meteorology, of the tropical meteorology, and then mostly with the observation from Yamanaka sensei, but you give more in terms of the mesoscale phenomena, and also like the MJO and others effects with the coastal process. But for us, more interestingly is, thank you so much for your looking at the how actually this kind of the meteorological and ocean process affects to the fisheries aspect, as you try to see the phytoplanktons, marine life, and etc. This is very important, and I believe they will inspire the student here. As you know, we have the number of participants about 209. It's a big actually class if you are in the school, and I believe most of them is a student here, undergrad and graduate student. Once, thank you again. Very comprehensive explanation about meteorology and ocean, actually, ocean and atmosphere. So now we are, now we are going to the last presenters. I believe this is also very important, especially we are going to the fisheries. So I think these three speakers is very complete now with Dr. Kati Longo. She's a principal scientist, science and standards, strategic research at the Marine Stewardess Council, MSG. And I think Dr. Kati Bios is his title is a principal scientist, as I mentioned already. So education is a master degree in the University of Rome. Doctorals she got from the University of Aberdeen, England, and her expertise currently is has been part of the expert group in US, Europe, and Australia on topics such as ecosystem-based management and data limited fisheries assessment. Also, collaborative multi-country project and multi-institutional efforts such as MSGs, data limited methods project. So to start the explanation, Dr. Kati, you have 30 minutes. So this is yours.
Thank you. Thank you so much. I'll share my screen.
Not yet. Yes, he's here. Yeah.
Yes.
Yeah.
All right. Well, first of all, thank you so much for inviting me and giving me a chance to be part of this lecture, and with some really fascinating presentations before me. And I apologize, my voice is not great right now because I just had a cold, so hopefully it's going to hold up well, and I'll be happy to take questions at the end. So without further ado, I'll go ahead and start talking to you about how, from the perspective of the Marine Stewardship Council, we think we can prepare for a sustainable future for sustainable fishing, even though we are in an age where the ocean is going to be more increasingly less predictable. So just to give you an idea of what I'm going to talk about, I just started lay out what I'll try to touch on. Hopefully I'm going to be able to keep within the time. So I'll give you a first introduction of the definition of sustainability, because that is what the Marine Stewardship Council has set out to do, and also thinking more broadly about sustainability. Tell you a little bit more about the program itself, so that you understand what experience we're coming from, and also how climate change is affecting fisheries that are within the MSC program, and what we think are solutions to maintain sustainability and adapt. And I'm going to also mention something about managing with limited data, because that is a concept that is very much linked to the challenges we have with climate change. And then I'll draw some conclusions. So let's start from the bad news, and that is that if we don't intervene, we already know from a lot of different kinds of predictions that overfishing will reduce the fish in the ocean, and also will reduce the benefits such as profits that we gain from fisheries. So here I'm showing you a graph from a paper from Costello et al. In 2016, I just picked out this graph because what it shows in gray is the trajectories up to now of the biomass of fish populations. And that's really the most common way that we look at the health of fish populations, as we look at the total biomass compared to a reference point. And then the trajectory turns into those shades of purple and red, and those are future scenarios. And as you see, the different shades of red imply that there are more or less profits tied to those different scenarios. And so through time, what we see is that the biomass will become less and less, and also the revenues will become less unless fisheries management is applied more rigorously. And the good news that we can get from another study is that actually what we know as best practice in fisheries does work. And so this is a study that was done looking at fisheries for which we have data and looking at their current trajectory. So I'll just walk you through those colorful lines and what they mean. So on the x-axis, we have time. And what this study is looking at is in purple, it's looking at how catch has been changing. So catch has gone up a lot, especially in the early 90s, but now catch is going down. And that is good news if that means that fishing effort is going down, because then it means that management is starting to be a bit more precautionary. And in fact, if you look at the green, that it's supposed to represent the fishing mortality, in fact, you can see that fishing mortality for these well-managed stocks is going down. And instead, the biomass, which is in orange, is the only thing that's going up. And that's also good news because it means that these populations are recovering. And that means that we have a good chance of being able to keep on fishing them in the future. So, so these two sides of the story are telling us that we do have some solutions, but we need to really get our act together and start implementing them. So the Marine Stewardship Council was born at the end of the 90s, specifically to address issues with overfishing. It is an international nonprofit, non-governmental organization, and it sets a fishery standard for sustainable wild-caught fisheries. So it sets a series of requirements that say what makes a fishery sustainable. And it also sets a chain of custody standard, and that is to ensure that the products sold to consumers with the MSC eco-label, which is a way of rewarding fisheries that manage sustainably, actually come from those sustainable fisheries. So this means that we are involving the whole production system. And what you see there, that cartoon wheel, is representing MSC's theory of change behind the program. And the idea is that by rewarding and incentivizing sustainability and sustainable practices, more fisheries will get certified and make improvements to become sustainable. More sustainable fish will be available on the market. More consumers will be interested and aware of sustainability, etc. And this will be a self-sustaining cycle. So what is in the fisheries sustainability definition that the MSC uses? Well, to manage sustainably, we have to balance the needs of people that want to draw benefits from fisheries and ecosystems. So we have to think about how much we're fishing, so make sure that the populations that we want to harvest have healthy biomass in their populations, which we call stocks, and how we fish. So we have to make sure that apart from what we are interested in fishing, we are mitigating the impacts we have on the ecosystem, on the sea bottom, on other species. And so in order to ensure that fisheries are meeting these requirements, the MSC standard applies the principles that were laid out by the UNFAO Code of Conduct for responsible fishing, not sustainable. So it is divided into three key principles. One is on the sustainability of the stock, so the key population that we're interested in harvesting. The second one is in mitigating impacts on the ecosystem. So we're making sure that all of the parts of the system, of the biological system, are healthy. And then the third principle looks at how decisions are being made above water by institutions and how fishing activity is being monitored. So we're looking both below and above water. I'm not going to give you a lot of detail on these requirements. This is just to show you that below these principles, there's different things that are measured, and that it's a rather complex and comprehensive approach. So assessors will evaluate a fishery against each performance indicator, and that they will assign a score, and a fishery to be sustainable needs to meet all of these requirements. So just to give you a sense of the reach of the program, currently there are 19% of what is estimated as the global wild marine seafood catch that is engaged with the MSC. And what engaged means is that many are certified, some are in assessments, they're in the process of being certified, or they've been suspended because they did something that didn't meet the requirements anymore, so they're trying to get back in the program perhaps. Or they're working towards certification. Of these, 20% are from developing economies and 19% are from what are classed as small scale. And then just quickly, just to give you a sense of also the distribution on the market, there's more than 20,000 products with the MSC label. There's almost 13 billion retail sales. There's 63 nations that are byproducts with this label, and 6% more volume of seafood that has been sold in the last year compared to the previous. But what we really want to know is, besides the fact that this program has been successful in reaching a lot of countries around the world, is whether it is credible and it is driving sustainability. So whether its theory of change is working. So I'm going to show you results from a paper that we just submitted. So I ask that you please don't tweet or put it on social media or copy it. And it's just a very simple graph. We looked at national statistics from fisheries around the world, wherever there are published assessments, and looked at the biomass of the population compared to the reference point that tells us whether it is being overfished. And I just mentioned, to please not share this graph. What I'm going to show you is in gray, fish stocks, so populations that are not certified to carry the MSC eco-label, and in blue, the ones that are harvested by MSC certified fisheries. And the darker colors mean that there are some populations that are below the overfishing limit. So what you see in blue is that most MSC fisheries, MSC stocks are not overfished. There's only a couple that fall in that category. In gray, you see that the ones that are not certified, there are many more, even though they are managed and they have stock assessments that fall under this underfishing limit. The ones that appear actually as overfished, this is just an effect of the fact that these data are in 2017, and the information about them being overfished was revised later on. So now those have been suspended once this information was available. So none of these carry the label currently. So this tells us that MSC fisheries actually target all sustainable stocks. But another effect, this is a market-driven incentive approach. And so what we care about is also to know whether it is able to create change within the market. And this is a result of another study that is going to be published in 2 weeks. We looked at the socioeconomic effects of the program in a few different fisheries around the world. And in particular, we were looking at albacore tuna in Canadian and US waters in the Pacific. And this graph is showing you who these certified fishers were selling to before they got certified on the left-hand side. So the buyers were both with a chain of custody certification or not. They were very similar, 47 and 53%. On the right-hand side, you see what happened after those tuna fisheries got their certificate. They preferentially started selling to buyers that had a chain of custody certificate. And that is because they would guarantee that they could sell their products with the eco-label. So it suggests that the flow of seafood through the value chain was changed because of MSC certification. And the fact that there is this market pull is really important to incentivize fisheries to make a change because they want to access those markets. So this is reminding us also that sustainable management is not just about the biological aspects of sustainability, but it's also about the social and economic benefits. And that's also at the core of how the UN Sustainable Development Goals have been defined, is really thinking about both dimensions, the nature dimension and the human dimension at the same time. The MSC standard only focuses on environmental sustainability, except for we have provisions since 2018 to make sure that there are no instances of forced and child labor. And so those involve some self-assessment audits, as well as some risk-based evaluations. And you can learn more about the details if you're interested in this MSC page that I put at the bottom. And we also have a paper submitted to Marine Policy where we analyzed these self-declarations from different fisheries around the world. So overall, then we are actually adding to our definition of sustainable fisheries. We're talking about how we fish, how much we fish, whether we are also providing social and economic benefits, whether there is fair labor conditions in place. But also the main topic today is that we are thinking also about climate change. So this consideration goes on top of all the others. And we need to make sure that we mitigate emissions that contribute to global warming that may be coming from fishing, and that we adapt to ensure that fishing remains sustainable, even though the ecosystem around is changing and even supply chains are changing. So thinking more about these two aspects of climate change responses, mitigation versus adaptation, I'm going to focus more on the adaptation component. One of the reasons why is that the impacts of fishing on climate compared to other food production systems are not very high. So this is a graph that I got from Oceana, but they in turn got it combining information from a couple of high-profile papers. And so what you can see in that yellow bar is that the contribution to emissions from fishing is lower compared to other more intensive and impactful land-based food production systems. So it's a relatively lower carbon emitting source of protein. On the other hand, this paper was published just a few weeks ago. So what you see in this graph is the evolution through time of biomass of wildlife in the oceans of the world. These authors is a large group of authors. They used a wide range of models and actually combined some of the biophysical modeling that we heard about from the two previous speakers. And they use that to then predict what is the likely change in abundance of the rest of the food web that is influenced by increased temperatures and all of the changes that come from that. So in blue is the evolution of biomass in the more optimistic scenarios from the latest IPCC report. And in red is the more pessimistic scenario. So you see that in both cases, even in the optimistic scenario, total biomass, so the total amount of animals in the water is going to go down. And if we are not going to be able to cut the global emissions sufficiently, this decline could be even about 20%, which is a rather staggering amount. So looking at instead what is happening right now and telling you a bit more about what MSC fisheries are already experiencing, I want to give you an example of what happens when the environment is changing faster than how managers are able to adapt. So what I'm showing you here is a map of a distribution of a small pelagic species, the Atlantoscandian herring. And this is a map of Northern Europe, Northern Atlantic. But this type of change is happening everywhere, all over the world. Fish are changing distributions, and these large populations that have different countries fishing on them cause conflicts because they are moving in new places. And those, what you can see here in yellow is where they were distributed until the early 2000s. And in orange, you see that the herring moved farther north and farther west because of changing temperatures. And so, for example, Iceland now has access to catches that they did not before. So they want to be able to benefit and fish. But in the meantime, the other countries want to still keep on fishing as much as they did before. And the result of this is that the combined pressure of all these countries fishing on this population is too much for it to be sustainable, and it is exceeding scientific advice. So in particular, there I showed you a map of herring, but this is happening for many pelagic species. One of them is mackerel that has a huge biomass, so it's very important from an economic perspective, but also from a food web perspective, and herring and also blue whiting. And there has not been a new sharing agreement, which has allowed all the countries to come together and agree to divide the resource in a way that it can be harvested sustainably. So right now, the combined catch for these species is 34% above what would be sustainable. As a result, they lost their MSC certificate because they can no longer be considered sustainable based on the Marine Stewardship Council criteria. And in the meantime, although there is some pressure and some interest in regaining these certificates, and some interest from stakeholders to resolve the situation, there still is no agreement. We are still at a standstill. So the solution will be eventually for coastal states and with the support of stakeholders to agree on a sustainable distribution of quotas. But in the long term, these changes are going to keep on happening. So what I'm showing you here is an example of something we're trying out in a project funded by Lemfest. This is it focusing on the US coast, on the east coast of the US. But again, these kinds of issues with stocks moving and across different jurisdictions are happening all over the world. And so what we are trying out here is a way of creating a rule that can adapt as the populations shift. And that is an online tool that can help evaluate how to shift the quotas as populations change how they're distributed. And there's a link there if you're interested to learn more about the project, but there's also many papers that have been published looking at this kind of problem. But something that is even harder to hear about is the price of delayed action on wildlife, especially when it is critically endangered. So in Canada, climate change has driven northern right whales, which are critically endangered, to new areas in the Gulf of St. Lawrence. You can see the map up there on the right, searching for food. And now these are areas where they did not used to be. So it has been common to fish for crabs using pots that have ropes that go to the surface. And these whales being not having occurred here in the past, there was no system in place to avoid them getting entangled. So these whales got entangled and died. And this was a tragedy for a population that had really been decimated by whaling until relatively recently, and now is still reduced to a few hundreds of individuals. So even losing a few individuals has a really big impact on the population. So these some of these were certified fisheries, so they were immediately suspended. And since then, Canadian managers, so the Department of Fisheries of Canada, DFO, has developed new adaptive approaches. So they change and they close areas when the whales are sighted, which means there's dynamic monitoring. There's marking of gears. So whoever puts gears in an area where there's a whale, they're going to be identified. There's flights to be able to spot the whales. And in addition, managers are working with fishers to create new kinds of gears that do not use these ropes so that we can prevent these kinds of incidents happening in the future. But the problem is that the early sightings started to happen a few years earlier, and before there was a realization and before managers and stakeholders agreed on what to do. In the meantime, several whales had to die. So this had a real cost. So in the end, there is an approach in place, but that time that it took to make those decisions was a problem for those fisheries. So overall, the lessons that we learned from the MSC perspective are that institutions need to adapt more quickly because climate change is moving faster than they are. And part of the issue is also that stakeholders need to push for these agreements and help reach these consensus more quickly. And this is especially challenging when there's multiple jurisdictions or different stakeholders involved. The other thing we learned, though, is that management best practice is that we have already identified to solve other fisheries problems is still providing tools that we can use in the case of climate change. So, for example, monitoring to check when the situation changes and using precautionary rules are tools that are already used in management best practice, and these work well for climate change. We just need to implement them more quickly and also apply them more extensively. So going back to our definition of sustainable fisheries, then we are adding a further layer. So we're thinking about how much we fish, we're thinking about how we fish, we have to think about maintaining social and economic benefits and ensuring fair labor conditions. And we also have to think about making sure we are mitigating or adapting to climate change impacts. But the challenge here is that not all markets are the same. So not every kind of fishery will, for example, respond to an incentive such as the MSC certification, and not all fisheries are the same. And we will not be able to have the same kind of monitoring everywhere, especially in places such as Indonesia that are incredibly diverse, where there is so much wildlife, so many different species to keep track of, and so many complex dynamics. What I'm showing you here with this map is from a paper that is on illegal fishing, so it doesn't have much to do with what we're talking about today, but the map is showing us, first of all, the very unequal distribution of certified fisheries. There are those dots in orange that are mostly distributed, for example, in Northern Europe, US, and Canada. But it also shows that the market leverage is different in different places, and that hatched line is showing where there are products sold. But then the greens are showing where there are supply chains, so different parts of that process that goes from catching seafood to consuming seafood. So these are all part of the same system, but they are more or less involved, for example, in the MSC program, and they are more or less able to meet the MSC requirements because they are requirements that require a lot of data. And we just heard that to adapt to climate change, we have to start collecting even more data because we need to monitor a system that is changing very quickly.
Katie, you have 3 minutes now.
Yeah, thank you. And yeah, I think we'll be on time. So in order to deal with the fact that climate change is creating new situations for which we don't necessarily have a solution or for which we don't have enough data, we can use management strategy evaluation. So this is a simulation approach that we can use to test, for example, if our rules are sufficiently precautionary, or to try and identify what are key sources of data that we might want to focus on collecting. And it can help to account for unknowns and uncertainties. So I'll very quickly walk through this, and this is just the final piece I wanted to present to you. So the way management strategy evaluation works is that this is all a computer simulated system. And we simulate our what we call operating model, which is what we believe is the state of nature. So how our natural resource behaves, our population, and also how fishermen behave. And then we can simulate what kind of information we are likely to collect from there. So we can also incorporate the kind of error we have, the missing information. And then we can apply a certain management approach, for example, a control rule. And then we can see what the effect of that rule will be on our fishermen's behavior, and in turn on the abundance and health of the population. And we can make it even more complicated. We can add climate change, we can add more species, and we could add some economic variables as well. And then what we do is we want to look at what the biomass of our population is likely to look like in the future under the different scenarios. So those different rainbow colors are the different scenarios. And we can also use this information to try and understand what information should we try to collect in order to monitor a system. So with MSC, we've developed an accessible version of this type of management strategy evaluation tool that can be used not for all of the possible complicated scenarios, but at least it's a starting point. And it can be used to try and understand what are the best available kinds of information we have, what are the likely impacts of the management we have. And we could start looking at things like whether there is some unusual signal in the system that tells us that maybe it's behaving in a new, unpredictable way, and we need to monitor the situation. I will not describe these graphs in detail so that we can just get to the end, to the final slide of conclusions. So one point I made is that sustainable fisheries require balancing people's needs and ecosystem resilience. And we also now need to think about how this will adapt to a changing system. We also can see that as an optimistic sign that the existing management tools we have can also be used to adapt to climate change, but we will need more resources, more monitoring. But we can also use some other tools, such as management strategy evaluation, to adopt more precautionary approaches. For example, if we have less data or we have more uncertainty on on how the system is behaving. So we have a mixture of good and bad news, I would say. We have some tools, but we are in a situation where we really have to start using all of the tools we have. And with that, I will thank you so much for your attention. I look forward to your questions, and thanks again for having me.
Thank you, Kathy. Give a big applause again to Kathy. And I think with all the presenters done, so we are going now to the discussions session. From the charts, I have some. I think I could raise the question firstly to from University UNPAD Imam. The question is based on Professor Manabu Yamanaka lectures. I would love to hear more about the mentioned natural disaster that affect some sectors, including infrastructures and populations, which I believe refer to the human. Does it actually leave us on more of the bad sides, since the activity will eventually continue and the damage has been done was just fuel loss? Or does it in some other ways live in others area? I'm thinking of the natures do actually let itself figure it out the real problem. For instance, atmosphere. Did you get the questions, Yamanaka Sensei?
Oh, sorry, I cannot.
Yeah,
I
they have
hear.
in the chat actually very long, but actually, if I can, oh yes, I think that's a good. No, just going to this one. Yeah, you have the time to read the question.
Yeah. Yes, yes. Yeah. Actually, I cannot have a time to discuss damage part of my lecture. So, anyway, I would like to, yeah, actually, mm, I prepared a slide for my COVID infection, and actually, simply speaking, the very high population density, like Jakarta or Tokyo, how to say, everybody knows that, for example, pandemic infection is more serious in high population density. It is because the distance of human distance is very short in such a very dense capital city. And this is the same, similarly, we consider the damage of natural disaster also on the high density area. So, for example, if same, how to say, disaster causing meteorological, climatological phenomena appear in capital city or in very, how to say, countryside region. Of course, the damage is bigger in capital city than in, how to say, countryside. So one idea is to separate, how to say, such a two big mega city like Jakarta and Tokyo for, how to say, some, how to say, smaller sub-cities. So actually, Indonesian government, I know Indonesian government is considering to move capital city from Jakarta to other place in Kalimantan Island, for example. It is one idea. So, but if so, if the governmental building moved to new capital, anyway, Jakarta is still a center of many business, many, how to say, industrial thing, many, how to say, journalism, etc., etc. So, if so, the big megacity, still megacity, but it is not good for considering the damage of disaster, etc., also pandemic. So, how to say, anyway, we cannot stop the natural disaster. We cannot stop the climatological or meteorological phenomena, but we can have, how to say, we can modify structure of society or structure of cities, for example, to decrease the damage of natural disaster. So I don't understand this is a good answer for the question or not, but yeah, so is it okay? I am misunderstanding the question.
Yeah, I think that's answered.
Yeah.
Sensei.
Yeah.
So is there any question to Claire in the chat? If not, I think I would take the time to asking you, Claire. It's very interesting actually when you mention us, especially focusing on the dinocycles. Very big from the model results, the bias, yeah, in terms of climate models in Indonesia. Do you have any more specific arguments how this comes, a bigger parts of the bias come from me as an oceanographer? I was thinking that we are not looking much on the in terms of the diurnals in the ocean. We have a like internal tide, a particle mixing actually, how the water mass with the colder temperatures come up to the surface, and this is periodically like a diurnal cycles. And as you give us very interesting himawari, yeah, the footstep of the diurnal signal actually mostly general or formulates like the islands. It shows us the strong signal of this diurnal. So if we look at this similarity with the ocean pumpings, particularly to the surface, especially the atmosphere, so it should be also sound on the atmosphere. I mean, in terms of the shorter periodicity. So, are you agree, or do you have some kind of reason about the big bias happening in the model?
I think it's a really interesting question. I think one of the reasons why the diurnal cycle in the atmosphere is so important is that there's a potential for feedback to larger scale processes. And one of the reasons for that is that once you sort of initiate the clouds and convection, then you can get the latent heat release associated with the condensation of water vapor. So I'm not sure if there's really an analogy to that in the ocean, but I definitely, as you say, there is the diurnal processes in the ocean, and definitely around some of the shallower waters closer into the islands, there's quite significant heating, diurnal heating in those waters as well. So yeah, I don't know if I have a good answer for your question, but I think it's a good point. Yeah.
Yeah, so I think this is the same, like the question come to the Yamanaka Sensei with the Nobel Prize, Yamanaka Sensei. Yeah, from hydrological cycle, yeah, we understand. Actually, you also with your student Reni already studied this quite well. But in the ocean, I think, in the ocean side, we don't much consider about this kind of like a pumping, vertical pumping, because of the diurnal internal tide cause the strong vertical mixing. So just notes, Yamanaka Sensei. But anyway, if you have some comments about this, the big bias in the model, in the maritime continent especially.
Oh yeah. Anyway, as Dr. Vincent showed, how to say, still there are many issues in modeling or how to say, realistic calculation on several processes related to diurnal cycle over the maritime continent. Because firstly, we need more observations, and secondly, we need to more, how to say, maybe some how to say, parameterization or some other skill to more appropriate in equatorial tropical region. So because many such skills are mainly made for mid-latitude phenomena. So some of them cannot be applied directly to tropical area. So anyway, we need more, how to say, studies. So I expect some of the audience, namely young students, start meteorology, climatology, oceanography from now on to study more the process in atmospheric and oceanographical processes in maritime continent region. So anyway, yeah, your question is important. So the diurnal cycle is truly local phenomena, but the effect is very large because maritime continent is very large, and as Dr. Vincent showed, how to say, diurnal cycle, local dynamic cycle appears almost at the same time along all the very long coastlines of the major island of the maritime continent. This is very great, and there are no such region in other, even other tropics. So, how to say, we need to study more. So, I am too old now, so I expect other speakers and audience, of course, should study more on maritime continent. Sorry.
Thank you.
Yeah.
Thank you, Yamanaka Sensei and Claire. So I think we are going to the Katie. There are a few questions, I think, I saw in the charts. Firstly, from the Talita, she would like to ask about what the impacts through the MSG monitoring and appellation frameworks, how the fisheries data works. Is it for the next scientific program or stakeholder or anything else? Can you get the question?
Yeah, well, I think if I understood, the question is around how we make sure that the program works, and how do we develop our monitoring and evaluation framework.
Yeah.
Right. And so I showed you just a little snippet of the work that we do, and I mentioned we have paper coming out that's focusing on stocks, but that's obviously just one part of the story. We also have some reports that talk about what do fisheries do to improve, and that's an important impact, and they improve during the certification, but also before. And in some fisheries have a long journey of improvement. And MSC works with some fisheries in Indonesia as well, actually, in a project called Fish for Good, as well as other fisheries that are aiming to get certified. So there are different parts of different aspects of improvement that we monitor in different ways. Some looking at ecosystem effects, some stocks, as I showed, but I didn't have time to show all of the studies that we do. And so I would say that I can't describe all of the results, but it's a very important question, and it's not easy to understand, because we can show correlation. We can't necessarily show that MSC is causing the change. We can say that MSC is part of what is helping to make the change, but it's usually never happening alone. So it's rather complex to evaluate.
Okay, so there is another question, Katie, from the University of Chester, Mia. How the most suitable strategy to communicate the most up-to-date scientific understanding of fish stock through MSG standards or MSG theory of change? How we know the MSG theory of change is effective? Oh, this one, yeah, on the screen.
Yeah, so I think that's also a very good question. I think it's the same answer, because really the monitoring and evaluation framework is evaluating whether the theory of change is effective. It's really breaking down the different aspects, the different assumptions in the theory of change, and testing them.
Okay, and other question is from Yvonne from University of Malaysia, Sabah. She asking to Claire, what is the most climate issues happen in the tropical countries, especially for sustainable fisheries in the tropical zones?
Yeah, so like I said, I'm not really a marine life expert, so I'm not sure if I can answer the sustainable fisheries part of that question. But I think in general, and this is a climate change thing more widely, is that, you know, we can look at temperature or rainfall or these things on their own, but the real impacts of climate change are sort of felt through the compound events of where things happen together, and you can't always untangle all the parts of those events. So I can imagine, you know, under climate change in marine areas, you're going to have a complex mix of changes in freshwater discharge, changes in sea surface temperature, changes in incoming solar radiation, and other things as well, I guess. And it's that kind of overall signature that's so quite hard to unpack.
Okay, so I think for the discussion, I would like to, I think the last questions, because of the time, I know in Australia, maybe now is 7:15 or something like that. Yeah, evening already. So this is the last question from the Nha Trang University, Vietnam. Sorry, Nha Trang University, Vietnam, yeah, means question to Dr. Kati, why we should focus on assessment data stock on efficiency standards is there any data we should concern regarding the climate on sustainable fisheries issue? How the most proper way to track and collect the global data?
These are a lot of very good questions, but they have different answers. So I don't know that we'll have time to go over all of them. I think the problem with climate change and with fisheries is that every fishery is different, and the main problem to address might be different. So I don't think there is a single answer on what data we should collect for all of the fisheries. It also depends on what we're trying to answer. Are we trying to get a big global picture of what are the most urgent problems? So I showed you some global studies, for example. Or are we trying to manage locally? When you're trying to manage locally, those global studies are not going to serve you. And it's the same as what Claire showed, for example, for oceanography. It's exactly the same for biology. If you need to manage a specific fishery in one island in Indonesia, you need to look at the local information. For example, that tool that I mentioned that does management strategy evaluation, the advantage is that you can tailor the tool to use the information you have available in that particular area and try and understand what are the best data sets that you can use. So I think that's the best way I can answer. But I know that it's a more complicated question, and maybe we need more time to get to all of those questions.
Thank you so much. So I think we have now come to the final sessions. I think we would like to give applause again to the very excellent presenters, the three most excellent presenters, Yamanaka Sensei, Dr. Claire, and Dr. Kathy. And we believe, I myself especially learned very much with these very interesting topics, and they give a rise some question. And for students, I believe, until now, they still have a 158. This is a big class actually. So I close the sessions for the moderators, and I give again to the MC.
Thank you so much to all of the participants who have asked the questions and were active in the discussion session based on the material that has been given. Moving on to our next agenda, we will give our appreciation to each speaker by handing them certificates. To operator, please display the certificates. In this matter, the certificate will be handed by the project officer executive. First of all, we would like to give the certificate to our first speaker, Professor Manabu Yamanaka.
Terima kasih.
Okay, I will lead the documentation session for the operator on my command in 3, 2, 1. Okay, next, we would like to give the certificate to our second speaker for today's webinar, Dr. Claire Vincent. For the operator on my command, in 3, 2, 1. And for the last one, for Dr. Katie Longo, we would like you to give the certificate for the operator on my command in 3, 2, 1. Okay, once again, on my command in 3, 2, 1. Okay, we will also be giving the certificate to Mr. Fadli, who led the sharing session as the moderator. For the operator on my command, in 3, 2, 1. Okay, thank you so much for the speakers and moderators to attend this webinar. Hopefully, the knowledge that has been given will be useful for us. Moving on to our next session, we will carry out a photo session. Therefore, we request all participants to activate your camera and give yourself some big smiles. I'll give you some minutes to prepare yourself. We all ready on the count of 3. Here I will lead the documentation session. Once again, to all participants, please activate your cameras. On my command, in 3,
Masih unmute, Mbak.
okay, before going on to the next agenda, we would like you to fill the attendance that has been given in the chat box below, so that later the certificate will be easier to give to the participants who have attended this webinar until the end. Ladies and gentlemen, we finally reached the end of the event. Thank you so much to the participants who have attended this webinar until the end with such enthusiasm. Once again, thank you so much for your participation in this webinar event. Hopefully, the knowledge gained will be helpful to the present and the future. I am Rushka as your MC for today's webinar. From the deepest of my heart, I do apologize if I have any mistakes during this webinar. Thank you so much and have a good day.
Thank you. Thank you.
Thank you.
Thank you.
Sensei, Square, Kathy, and others.
Yeah.
Thank you so much.
Yeah.
Thank you so much. Bye, everyone.
Yeah.
Thanks, everyone. Bye.
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 Thank you so much.
Have a nice day, guys.
Yeah.